Let's evaluate the given limit 13 ln x over x as x approaches plus infinity, maybe using L'Hopital's rule. When I say maybe means I need to check first if I'm allowed to use it. I can only use L'Hopital's rule at infinity over infinity, plus or minus doesn't matter, or 0 over 0 cases. Let me imagine what's happening at infinity with 13 natural log of x. If you remember, log of infinity goes to infinity. Either you remember it through graph, log behaves like so, it slowly increases to plus infinity. Also numerically, you can plug into log some massive numbers like 1 million, and you'll see that the number will be also huge as the output. Multiplied by 13, infinity is still infinity. And then if you plug infinity into x, it also gives you infinity. Thus, by the way, this equal sign is not correct, it's just annotation-wise. Thus, we are allowed to use L'Hopital's rule. I will again show you a notation that is popular in Europe, which is, I'm putting infinity over infinity here as a node, and I will put LH to remind future myself where the next step came from. And the next step is that now I'm taking derivative of the numerator separately and denominator separately. Okay, derivative of x is simple, that's just 1. Derivative of 13 ln x, hopefully you remember, will give me 13 over x. Let's simplify carefully. It will give me limit as x approaches to plus infinity. 13 stays in the numerator, x goes down to the denominator, 1 is still in the denominator, I don't have to write it down. Now, as x approaches plus infinity, 13 over x shrinks to 0, because dividing by the biggest numbers you know gives you the smallest number you know. That's kind of one of the ways you can remember the idea. You can also try it numerically if you want. What is happening with 13 over 10,000? It's a small number. 13 over 100,000, even smaller. Graphically, the same thing. 1 over x behaves like so. So at plus infinity, it shrinks to 0 times 13. 0 is still 0. So that is the final answer. Good job for watching and keep working hard.